So today we're going to do another performance testing video on gRPC services, but this time we're going to do an incremental load. So on the previous video we did a performance test, but we were using constant load. So that means the number of threads that we are generating that is calling the client, the gRPC server was constant. And this time around, we're gonna configure it in such a way that the number of threads or the number of virtual users that we are trying to simulate is increasing over time. All right, so let's get started. So you're looking at my on my screen. You'll see you're looking at Fint. And as always, in order to start a performance test, you need to go to click on the performance menu over here. And over here you see the ones that we've done before, the get features for the constant load. So as a brief recap on how to create a performance test, let's go ahead and create one for the incremental load. So let's click on that create button, and let's say get features, give it a name, get features. Let's say this is going to be an incremental load, so let's name it as such. And of course, client type is support. We will choose gRPC, but as you can see, Fint supports REST and WCF as well. And as always, we'll be using the root guide client that we've used on the previous videos. And we'll be testing the UniRecall, the get feature async method. Right, so everything's ready. Let's click go, and there it is. So we now have our performance test, and for the incremental load, and let's go ahead and configure it. Let's click on this button over here, open within the window, the open, and we have this now, the performance test and empty screen. So since we will be doing an incremental load test, for the load type, we're going to select this time around, we're going to select the incremental option. And you can see here from the default that it tells us 100 virtual users. We're simulating 100 virtual users, and each user is the ramp up time is 1000 milliseconds. So that would mean every 1 second we're going to create one user, or in this case, one thread. And the invoke interval of 0 means that one client will make a call, and immediately it will make another call. So there's not going to be a wait, a delay between the calls. But let's say we'll just add, say, 10 millisecond delay between the call, and the duration is 300 seconds, so about 5 minutes. So let's for the purpose of this video, let's just make it shorter, so around 3 minutes, let's say, so about 180. And let's click save. And of course, this is the details tab for the test. So this is the configuration for your performance test. We also need to specify the input, the request that we're actually going to send out to the gRPC service. So click on this input tab and hit the request in this tree view over here, and check that. And then let's add some latitude and longitude values. So let's go back to our root guide service that we've been using before. So this is the root guide service, and there's a JSON database over here that contains all the latitude and longitude values. So let's just go ahead and select one. So I'll click this latitude, and let's do the longitude value. Right, and okay, so we're almost ready. So we can now start our performance test. But before that, of course, we need to run our service. So let's go ahead and run the root guide server. So let's right click that and say debug and start new instance. Okay, and it should be spinning up now. Yep, there it is. It's coming up. And yeah, right. Now let's just right now Visual Studio is attached to it, so It's gonna be slow if Visual Studio is debugging, so let's detach from that. All right, and okay, so there it is. So our root guide server now is running and it's listening on port 5052. And we have a quick look at that get features method of the service. Let's see, root guide, and let's go to that get features method, which is just so actually it's just it checks the features that is, and it has an in-memory database of latitude longitude values. It will check that and it will just give a response. And I've added this console.write. It just prints a dot into the console screen so that I know that when the service is running, or when the running performance test, if I see that dot running across the screen, then I know that the service is being hit. So since everything is running locally, so this should just go really fast. So now we have a server running. Let's go and try that out. Okay, so now we have configured for 100 virtual users and with a ramp up of 1 second. But as always, services, gRPC services, WCF or REST service, before you run any performance test on it, you have to warm up the service. You have to make sure that it's properly warmed up so that the measurement values that you're getting are actually representative of the actual performance of your service. So let me just go ahead and change again the settings of this. So instead of 100 virtual users, let's just warm it up with let's say just one user, and let's just change the duration to let's say 30 seconds. I'll click and save that, and we click run. So now we're ready. So we're ready to warm up the service. Let's hit run. Let's go back to my console. So now you see that the dot is running across the screen. I know that we know that the service, the gRPC server now is being called. And we see here also the plot is updating. Over here on the big one would be the response time, the maximum response times that are measured within every second. There's a time frame, so every second it will make a measurement, and then it's the max one is you see over here. The blue one is the percentile was 95%, and then the purplish one is the average. Okay, so since we're just warming it up, well, you can see the service is yeah, pretty fast, so 3.86 milliseconds, and it can easily handle one user. So let's ramp it up a bit, and let's make it now our 100 virtual users, but we'll ramp up, so 100 virtual users, one user per second, and invoke interval of 10 milliseconds, and we'll change now our duration to 3 minutes, so 180 seconds. Let's hit save, and let's run this again. Click run, and let's see. Let me go back to so our service is running, and that dot is just running across the screen. And I'll just put this aside first. And now here you see our service, and now we're at over here we're at 28 virtual users. So every second one virtual user gets added, and of course it's as we expect. It's a initial. So the more users that gets, the more clients that's calling the service, then the rate that the number of responses that we are processing per second, of course, will increase, because now you have more users, you have more virtual users calling the gRPC server, and it's keeping on steadily increasing. And really the goal for this type of test, for incremental test, is that you want to set up your test so that you will keep on incrementing the number of users, and so that you will find out the actual number of users that your service, or that can handle. Or you want to get the number of users where at some point if you exceed that, then your response time goes higher, or your rate over here is going lower. But currently here, from what we see on the service, you can see that we are now up to 100 virtual users, and we have a rate of about 1,300 responses per second. It's doing just fine. I think somewhere over here. So now at 100, it's somewhere the response rate is lower. So definitely. So at so when we reach that point, then that means at 100, then the service is now getting a little bit, let's say, overwhelmed with the number of requests that it has to process. So that's why the rate has dropped, as you can see over here. And you can also see from the graph here on top, if I expand this a bit so that it lines up, you can see that around this part, around 2 minutes to 20 seconds, you can see that we have the average response time, the purplish one, has actually gone up. So around this part, around this time, that the average response time is actually has gone up. That and then you can see that effect as well on the on the service, that the rate that the service can handle each request has also started to come down. So so these two graphs here, where we see the average going up and then the rate coming down, actually is lining up. Just to indicate that at this point your service is not able to cope anymore with with all the requests that are coming in at the same time. Okay, and yeah, I think so. That's finished. So 3 minutes is up. We had 100 virtual users, and we managed about the service was able to process 222,000 0.6 responses. Great thing is we didn't have any errors, and yeah, and the average is 47, and the median, average and median pretty close, so that's good. But we have this max value, so that's pretty far from the average. And this one, so when you see these values, where like here on the main graph over here, where you see these peaks, the max value is pretty far from the average. Like over here as well, pretty far from the average. That could indicate that, especially over here on this side, that could indicate that the service is not really able to handle now every single request. And if you check on the documentation for gRPC on the Microsoft website, it says that the the clients, there's a maximum number of connections that it can handle concurrently, and then if you reach that maximum number of concurrent connections, then the requests are going to be queued on the client side. I think that should be somewhere on the Microsoft website. Let's go quickly find that. Microsoft gRPC performance. Let's click on that. I think I saw that last time. Here, yeah, all right. So connection concurrency. Okay. So a gRPC channel uses a single HTTP2 connection, and concurrent calls are multiplexed on that connection. So when it reaches the number of active calls reaches the connection limit, additional calls are queued on the client. And then the queued calls wait for the active calls to complete before they are sent. So what that would mean is that you will have these peaks, it could indicate that these requests are being queued. So that's why when Fint sends that request, the timer start, but actually the request was never sent out yet to the server. But the timer on Fint is already started. And then so that when it comes back, then the total time that it would take would include the time that the request has spent on the queue. So it will be the time spent in the queue plus the processing time with gRPC servers, and you will see this that could lead to these peaks like what you see over here. But of course, if you want to have to just to get a general overview on how your service is going to fare given the settings, without on the assumption that you didn't reach that maximum limit, that then you could actually make use of the of this over here on the upper right corner. There's a button to remove the outliers, just because you can see that in relation to the other points, right? These peaks over here, they're actually outliers. So if we remove all that, then we will have a value or a chart that would represent like the general generally how your service is performing. So let's click on that, remove outliers, and let's see the difference. Click that. Okay, and now you see the graph has changed, and now it's more uniform. So the peaks are gone, and we see the maximum of the performance of the maximum response time for the service is somewhere around below 180 milliseconds, and but we still do see the trend that as the test was progressing, that the average time was also increasing. That also lines up because with how we configured our tests, because as the tests progress, we are adding more and more virtual users. So every second we're adding a virtual user, so that means more and more load on the gRPC server. So that would mean, of course, if more load means it will take more time to do to handle each of the requests. So that would show up as an increase on the average. So the more the average increases, of course, the average response time increases. Then of course the response the rate should also drop. Bring this back, and over here on this the bottom part, you see there's a response time distribution. So although we see that the graph the average is increasing and the rate is decreasing, what you can still see that the overall based on the distribution of the responses, that the service was actually pretty fast. So it's serving a good. This is about 10%. So 10%, or this is roughly 10. This bar is 10%. So 1, 2, 3, 4, 5, 6. So less than about this in total. This is about like what 60% of the requests are below 36 milliseconds. So that's the services. I think it's able to handle the requests just fine for the majority of the requests. Of course, some of the requests are took longer to handle, like these ones that are coming in now at 100 milliseconds more. Okay, and yeah, so that's it. That's an incremental load test for gRPC servers. It's pretty simple. Just configure your test, select the load type as incremental, and then configure your virtual users, how many virtual users you want to target. Configure ramp up time. For the purposes of video, I configured it for 1 millisecond. But for your actual test, so you should actually consider this. You should consider your actual user scenario, that your service will be, that the clients of your gRPC server would be ramping up. So 1 millisecond may be too fast, so maybe 10 seconds or so, or even more. So just configure it over here. And then of course your test duration would be something that's longer, maybe 30 minutes to an hour perhaps. Okay, and then of course at the end of the test, if you want to have a look at the revisit this test in the future again, so you can always click save, so that all these graphs over here, how the service performed over time, and then this overall values over here will be saved. So I click on save. So if I click back, I could open that up and see that, open that again, and we should get back the same charts. That did not save. Right. Okay, so thanks guys. Although that did not save, I'm not sure why. So thanks anyway. That's the incremental load, and yeah. So on the next video, we'll have a look at the burst load, and then we'll see how that differs from the constant load and the incremental load. Okay, cheers. Thanks. Bye.